right. My name is Mohan Kumar Silperseti. I'm the co-founder and CEO of Trendwise Analytics. I'm here to do a session on artificial intelligence and deep learning. How many of you are familiar already with artificial intelligence? Deep learning, machine learning? I think you've done machine learning, right? Okay, all right. So this is basically kind of an extension of machine learning. So my brief was to talk to you about artificial intelligence, deep learning, and some of its applications. So that's what I'm going to do. Let's start with the video.
It all begins from a single origin, a unique point in space and time. This is the spark of innovation that fuels your most amazing breakthroughs. It's a passion for discovery that unveiled the genesis of all that exists in the universe. Today, the power of AI helps computers achieve superhuman capabilities in image recognition and lets scientists save our most precious resources by analyzing in 1 month what used to take 10 years.
是谁发明了机械计算机？
Everyday devices translate even the most complex languages from voice into text and images into words.
Xavier is now present.
Helping the visually impaired recognize an old friend, or letting a blind woman read to her child for the first time. Autonomous vehicles give us the freedom to reimagine our city streets and travel where there are no streets at all to help the lost find their way home. We see robots teach themselves to perform simple tasks. We even watch in awe as they take their first steps. And today, a 2,500-year-old game meets its match as a computer competes with one of the greatest human champions of all time and wins. This is the collective imagination, fueled by forward-looking technologies and the beginning of your most amazing discoveries yet to come.
Slides. Okay, so what we are going to do is spend the next 2 hours talking about artificial intelligence. I'll take you from a very high level, introduction. We'll go a little technical, and then we'll see what are some of the applications. So 1 hour we'll spend on introduction, and the next hour on some of the applications. By way of introduction, I've been in the industry, as I said, my name is Mohan Kumar Silperseti. I've been in the industry for almost 25 years. I'm a graduate from IIT Kharagpur, and I've worked for SAP Labs and IBM for almost 20 years before starting my own company, Trendwise Analytics. And we do a lot of machine learning, deep learning, and AI. Okay, so that's very briefly about myself. So we'll keep this session interactive, so feel free to ask questions so that it is not a one-sided info transfer, right? Okay, so something very fascinating happened on 2016, March 15, 2016. The computer or AI system AlphaGo defeated the world champion of the game called Go. Have you heard about this incident? Any one of you? No? Right? Okay. So unlike, let's say, chess, I think many of you would have heard about the chess incident, right? Yes. So unlike that, this was somehow low-key, but this is also extremely, extremely significant. So what happened on this day, DeepMind is a company, basically a startup in UK, which was now acquired by Google. Okay, they developed a system which defeated the human champions of a game called Go. And one of the tricky parts of this game is that it's not very complicated. So it doesn't have a lot of rules and regulations, unlike, let's say, the game of chess, right? So chess has a set of rules. So actually it is relatively easy to write all those, configure or write code all those rules, and even predict what your, if you perform a move, what will your, what are the various moves that your opponent can perform. But unlike that, Go is actually a very simple game with very few rules. So that is the actually very complicated to write a program, right? And that's why this kind of becomes really, really very significant. A lot of people thought this will take almost 10 years to achieve this kind of a situation, but these guys achieved in 3 years. So that's very, very significant in terms of artificial intelligence. That's a very significant move. So what's the big deal? Anybody knows how many numbers are in this? I'm not talking about digits, numbers. This is just one number, by the way. Okay, this is the number of possible moves in the game of Go, and apparently this is larger than the total number of atoms in this universe. Can you imagine that? Okay, so again, the idea here is that this was more an intuition based game, so that's the reason there are so many possibilities, and therefore it's not really easy to write a program to play this game. Okay, so how did they achieve it? They basically did it using artificial intelligence and deep learning. We'll come to that. A little bit about Go, in case as I see many of you are not familiar. So this is a Chinese board game. The board looks somewhat like checkers or chess, but it is very different. It is a 19 by 19 square board, and there are two players, as you can imagine, and it is obviously 2,500 years old game. And the rules are very simple. Each player has to just put a stone, white or black stone, at the intersection of these lines. That's all, as far as the moves are concerned. But in the long run, it has to be in such a way that they can capture a territory, and the maximum territory whoever captures. Okay, so by surrounding your opponent's stones, you actually can also capture their stones and territory and so on and so forth, right? So that's basically the philosophy of the game, right? So this is a lot more intuition based, and it needs a lot of practice. All right, so AI is already here. Many of us are probably interacting with AI, in some cases maybe unknowingly, but at least we would have heard about it, right? Autonomous cars, many of you, Google's autonomous cars, many of you heard about it. It's not yet in production, but already they have driven millions of miles. Some of you may be using iPhones, so Siri, right? Some of you use Siri. That's actually nothing but AI. Chatbots. Some of you may not even realize that you're interacting with chatbots. Nowadays, chatbots have become so smart. Then, of course, robots you would have seen at least somewhere on TV and things like that. So it's already kind of here. We'll see a little bit more in action as we move forward. How many of you heard of Watson? IBM's Watson? Yeah, have you heard of? Right? Yeah. So basically, this was somewhat a small step towards this direction, but that's still not really, we don't, at that point at least, we did not call it AI. So Watson is again a supercomputer, somewhat on the lines of a little bit more advanced than Deep Blue, right? That was used for defeating Garry Kasparov in chess. But this is a little bit more advanced, unstructured data and so on and so forth, using the concept of big data. So when Deep Blue was there, we did not use big data, right? This uses big data, unstructured data, and so on and so forth. And so they pitted against Watson. They pitted Watson against the human champion, and that was the significance. And Watson defeated the human champions of a game show called Jeopardy. Okay. Again, that was also not very straightforward, because Jeopardy is a game. It's somewhat like a quiz, but it is not really a quiz, because here you're given a clue and participants are supposed to come up with the question. right? And there is no kind of scope defined. This can be anything under the sun. The topic can be anything under the sun. So has anyone seen the video of Watson, the game, Jeopardy game? No? Okay, so it may be interesting to play this video.
We're going to treat you to
Volume.
a short round of Jeopardy. It's going to be hosted by a member of our Jeopardy Clue Crew. Please welcome Jimmy McGuire. Gentlemen?
Good morning, everybody. Thank you for being here. What do you say we play Jeopardy? Let's get right into the Jeopardy round. These categories: a man, a plane, a canal, Erie, Chicks Dig Me, children's book titles, My Michelle, MC5, and finally, vocabulary. Ken, you're in the first position. Please make a selection.
I've never said this on TV. Chicks Dig Me for 200, please, Jimmy.
Kathleen Kenyon's excavation of this city, mentioned in Joshua, showed the walls had been repaired 17 times. Watson.
What is Jericho?
Correct.
400, same category.
This mystery author and her archaeologist hubby dug in hopes of finding the lost Syrian city of Urkesh. Watson.
Who is Agatha Christie?
Correct.
Same category, 600.
At the Olduvai Gorge in 1959, she and hubby Lewis found a 1.75 million year old Australopithecus Boise-eyed skull. Watson.
Who is Mary Leakey?
You're right.
800, same category.
Harriet Boyd Hawes was the first woman to discover and excavate a Minoan settlement on this island. Watson.
What is Crete?
Yes.
Let's finish Chicks Dig Me.
At Mount Carmel in Israel, Dorothy Garrod was the first to find this prehistoric human skeleton outside of Europe. Ken.
What is Neanderthal?
You're right.
Let's go to children's book titles for 200.
Marjorie Williams' story of a stuffed toy that comes to life, the blank rabbit. Brad.
What is Velveteen?
You're right.
MC5 for 200, please.
He's worth every penny as Alfred Pennyworth in The Dark Knight. Brad again.
Who is Michael Caine?
You're right.
MC5 for, let's jump down to 800, please.
Edgar Degas' style influenced that of this female American impressionist. Brad.
Who is Mary Cassatt?
Correct.
And MC5 for 1,000.
The film Gigi gave him his signature song, Thank Heaven for Little Girls. Watson.
Who is Maurice Chevalier?
Correct.
Same category, 400.
The parents of this 52nd governor of New York immigrated to the United States from Salerno, Italy. Watson.
Who is Mario Cuomo?
Correct.
Let's finish MC5.
This child star got his first on-screen kiss in My Girl. Ken.
Who's Macaulay Culkin?
Correct.
Children's book titles 400.
By Judith Viorst, Alexander and the Terrible, Terrible, No Good, Blank, Blank Day. Ken.
What is Very Bad?
Correct.
Book title 600.
By Dr. Seuss, The Blank Hats of Bartholomew Cubbins. Ken again.
What is 500?
You're right.
Book titles 800.
By Maurice Sendak, In the Blank Kitchen. Ken.
What is Night?
Correct.
Book titles 1000.
A classic by Crockett Johnson, Harold and the Blank Crayon. Watson.
What is Purple?
Correct. Taking you to 4,400 and taking us to our first break. We hope you enjoyed it. I certainly did. We'll be right back after this.
So this is what Watson was, right? And I think you all did this big data course, I guess, right? You're familiar with Hadoop and so on and so forth. So just to go a little bit deeper, so this was not like, the system was connected online and it was just went and it just Googled up something. No, it was not. So it was fed a lot of text about a variety of topics, and it actually analyzed all that text using natural language processing, and it was obviously also trained to play this game. Okay, and as you have seen, it will, based on the clues, it will try to come up with 3 possible answers, and this has been there is a threshold set that if you're confident more than, let's say, 90%, only then you do the equivalent of pressing the buzzer. So unless, even though it knows the answer, you must have seen towards the end there were a few questions where it knew the answer, but it did not press the buzzer because the threshold was set at about 90%. So that's how it worked. So it was completely offline. Hadoop was the underlying architecture and underlying technology rather, and text mining was used. So it is a one step towards machine learning and AI and deep learning, but still it is not there. So these systems are still known as what is known as artificial narrow intelligence. We'll talk about this. So what are the other applications that are possible these days? They call it now, IBM usually calls it cognitive platform. So IBM's Watson actually, that was what you saw there was about 5 years back maybe. So obviously they further evolved it into very specific areas, and they have developed a healthcare system whereby Watson will be able to take or see the images, analyze the images and detect if there is cancer, right? And they have tested it, and it does up to 90% accuracy. Again, they are doing this in the US. In addition to that, there is a AI-enabled attorney called Ross. And you can imagine, right? So some of these areas, it really depends on a lot of knowledge. So medical is obviously one of them. Every doctor, even though he may be a specialist for several years, but obviously it's not possible for him to know all possible cases. Same way legal. Every lawyer will not know all possible cases. So that's where these systems can help. So Ross is one of those systems where it is fed with all the legal cases probably throughout the country or throughout the world, and it will try to identify where similar cases were solved or argued and so on. And there is another system in the fintech space, which is financials, basically investment analytics, called Kensho. And then I've listed Manthan, which is an Indian company, but something more advanced than that I will demonstrate to you, which IBM has come up with, which is interacting voice, interaction to get details about these reports and so on and so forth. So yeah, these are some of the work is still happening. In fact, Google is trying to find a cure or predict and prevent blindness. In fact, I was thinking of showing a demo of our application. We also developed a similar application, but unfortunately, I won't be able to use my laptop. But it is available on our website, trendwise.ai, in case you want to test it out. So it basically takes images, what we call as fundus images of the eye, and it will say whether the eye is defective or clean or clear, right? So Google is doing much more, and they are trying to even classify them, saying if the disease exists, to what extent it has gone. So that takes a lot more time. We are still working on it, but Google is obviously ahead of that, right? And many similar possibilities are there. For example, cancer, and already we have seen Alzheimer's is another area companies are researching. So there are a lot of startups doing work in the healthcare space. Then, as I mentioned, automotive, of course, is in the autonomous cars. Pretty much now every car company is trying out driverless cars or autonomous cars. Google started the trend, but then now Tesla, then we have even Toyota. Everybody is into this. We'll talk a little bit of this as well in the second section when we talk about the applications of AI. This also, I'll show you a demo of this. So how Alexa is a voice-enabled, similar to Siri, right? So it is Amazon's voice-enabled AI application. IBM has actually developed a small demo how you can use voice-enabled system and integrate with their analytics, and how you can basically replace a service representative, right? So somebody who takes the call and answers your questions, they have shown a demo where you can completely replace, right? So this is again another area of this is robotic process automation, RPA. I will touch upon that as well, and I'll show you a few POCs that we have developed in this space. So this comes under that category. So what is the AI? We've talked already a lot, but what is the AI? So this AI is, artificial intelligence is not entirely new. Actually, this word was coined way back in 1956 by a professor called John McCarthy of Dartmouth College. And they, in fact, even started a project. They got some funding, and they even started a project to do some research in this space. And they did for a couple of years, and it had to be kind of put it in the cold storage because the computing power that was required was not there at that time, right? So that is also known as the winter of AI. So there was a huge gap. And then once the computing power in the late 90s started increasing, people started working, and then this became again a very hot topic. So today it is really very hot. AI is, everybody talks about it. Every company wants to implement AI. Every startup says it is a AI-enabled product they are developing, right? So it is definitely the flavor of the day. So AI is classified into three types. One is artificial narrow intelligence, artificial general intelligence, and artificial superintelligence. So we are still in the area of artificial narrow intelligence. We are slowly entering towards artificial general intelligence, and the game of the AlphaGo or that system, development of the system, is one step towards artificial general intelligence. Now, what is the difference between these two? So artificial nano intelligence is basically a system which can do one particular activity but much better than human beings, right? So that is somewhat like let's say the Deep Blue application or Deep Blue system that was developed. It can play chess very well, but then you ask it to do anything else, it will not be able to, right? Artificial general intelligence is something like it should be able to do at least 5 or 6 activities. So it should show intelligence in doing some of at least 5 or 6 problems, solving 5 or 6 problems, right? So that is basically general intelligence. Now super intelligence is somewhat a little bit of a scary thing. A lot of people are scared and worried about this because this is something that the system can do many things much better than human beings, right? So it is like competing or even better than human beings. So this is also known as singularity, and that's why a lot of people are worried that if such a situation arises, then these systems will take over the world and they may wipe out human beings and so on and so forth. I don't believe in that, but that's some of the. But a lot of other people are very happy if this thing happens, because then you can imagine we don't have to really work for a living, right? So it is a very happy thing where you can just enjoy life. The systems will take care, and that's a very serious possibility, by the way. Okay. So this is how the graph looks. In order to achieve singularity or super intelligence, what it basically says is that it took us a lot of time to even to come to narrow intelligence, ANI, right? And from narrow intelligence to general intelligence, probably it will take a decade or so. But once we achieve general intelligence, from there to super intelligence will be very quick, very rapid. That's what it says. Okay. So there is also a lot of confusion about what is AI. Is it just robotics? Is it just machines, or is it just software? Is it hardware? So this slide basically tries to bring some of this together under one umbrella, so that we get a little bit of a hang of it. By and large, this is about wherever we use things like vision, voice, or text, right? These are a little more complicated than regular data processing, right? So wherever these senses in a way are involved, that's by and large what we call as artificial intelligence. And within that you have, of course, robotics, which is basically you apply all this, and then the mechanical part is the robotics. So it is a combination of hardware and software, but you can have AI without robotics as well. That's still AI. And therefore there is like image recognition, speech recognition, natural language processing, and all that. All this comes under AI. So why suddenly? As I mentioned, it's not really suddenly. It's been there for quite some time, but now the revival of AI is happening because a lot of things are coming together and falling in place. And not the least is from a hardware perspective. Okay, so I'll touch upon that. But before that, now, as I said, in 1956 this concept started, but there wasn't enough computing power. Now we have a lot of computing power. Moore's law is almost saturating, by the way. And then we have big data to handle the data. Big data concept we have to handle large amount of data, because machine learning, deep learning, AI is all about analyzing existing large amount of data and training your system with that. Then you have the cloud, right? So if you need, for a temporary period, if you need a large amount of processing, like we, for example, we needed some GPUs to train our model, which was taking almost weeks on our systems. We just put it on the cloud. Within half a day, we got the model ready, right? So that kind of thing was not possible earlier. So all this put together, plus there is a lot of innovation happening in the hardware area as well, which is the GPUs. GPUs were there before. I think you must be familiar, the graphical processing unit, right? So, but they were earlier used mainly for graphical interface, so in games and all that we were using. But we knew that they were very good at doing certain things, which is more like parallel processing. So if you have a 10 by 10 matrix multiplication, which is very common in, let's say, in deep learning and machine learning, better than a CPU, the GPU does much faster, right? Because of multiple cores and so on. So there's a lot of innovation happening in this space. NVIDIA, I think it is really at the right place at the right time. NVIDIA was always there for GPUs. They were the manufacturers of GPUs. They are really exploiting the situation, because now they are putting everything, and they're making AI enabled. They're putting this in autonomous cars. They're coming up with open source software or operating system for autonomous car. Any one of us can just download that and build a UI on top of it and build a autonomous software for autonomous cars, right? So NVIDIA is doing a lot of work here. Obviously, others are not to be left behind. So Intel is now developing AI enabled or AI powered chip, if you will, and so on, right? Plus a lot of investment is happening. So for example, Elon Musk has jumped into the fray. Toyota is investing about $1 billion to work in the area of AI. So a lot of stuff is happening. So that is the reason for the revival of AI. Now, so what is underneath? What is the technical platform or technology that is underneath AI? By and large, it is deep learning, right? As I said, there is of course the hardware part of it, the mechanics part of it, which is robotics and so on and so forth. But from a software perspective, it is mostly deep learning. And so what exactly is deep learning? It is a part of machine learning. So let's quickly, I understand you all are familiar with machine learning, right? You already did machine learning? Yeah, okay. So we don't have to spend a lot of time. So machine learning is basically enabling the system to learn from, let's say, previous data or something like that without specifically coding, right? So that's the key difference. You don't write line by line the code, just like you teach a child, right? So when you teach a child, let's say you want to show an apple and say, okay, this is an apple. You really don't tell the child, okay, this is the shape of the apple, this is the color of the apple. You just say this is apple, the child sees, and next time it recognizes. So it's somewhat, that's why it's called learning. That's the difference between, right? So machine learning is that you're teaching the machine how to identify patterns, recognize patterns, and so on and so forth. So there are two types again there, right? So the one is, so we'll just talk about that. So primarily ML consists of, by and large, three components. One is there is a little bit of programming required. So we write some programs in let's say Python, Scala, and so on. But by and large, it involves a lot of algorithms and statistical models, and of course, data and data mining, right? Large amount of data and data mining. And then, as we were talking about, teaching the system or teaching the machine. So basically, there are 2 or 3 types of machine learning, primarily supervised and unsupervised. And now we have more in the area of deep learning. We have reinforcement learning. We will take a look at some demos of that as well. I think you're all familiar with this, right? You already did deep learning. Machine learning. So some of the processes, again, you are probably familiar: classification, regression, clustering. So clustering is what we do when we do unsupervised, yeah, right? And then clustering and classification. So this is the method that we follow for the learning process. So you have a large amount of data based on which you want to train your system. So you first decide on what kind of a model you want to build, and you decide on the model, and then you train the system, and then you have the trained model, and then you may test it, right? So you have a small portion of your data for testing, and then you deploy it to actually get the inferences from the actual data. And you may find that when you're doing that, there may be inaccuracies, right? So you don't get it the first time, then you may have to go back and tweak your model. So there's a lot of what you call trial and error happens in this. Okay, so it is never that the first time somebody configures or creates a model and trains it 100% it works. It doesn't happen like that. So there is a lot of iterative process that goes through this. Coming back to, so basically deep learning has all these components, and it is, by the way, it is a subset of machine learning. Okay, but the main difference is that it uses artificial neural networks, right? Neural networks is the secret sauce of deep learning, and the word deep also comes from this, because neural networks have multiple layers. So that's where the word deep comes from. And this is basically an attempt to simulate the human brain, right? So it's been seen that human beings learn using our brain. So can we simulate the brain? And the neurons are a part of the brain, and that is basically what artificial neural network consists of, artificial neurons. And as this picture depicts, we have almost billions of neurons, but even a small creature has maybe at least a few thousands of neurons or millions of neurons based on what level of evolution it has gone through. So that's the idea behind neural networks. So artificial neuron looks like this. Again, this is very similar to our actual neurons. They take the inputs and then they give out an output, right? So even here, the neuron takes multiple inputs in the form of x1, x2, and then it basically multiplies it with some weight and then a bias, and then it gives an output like a yes or a no kind of a output. So this is predominantly how classification works, and these are known as activation functions. That's what is used as an output. Sigmoid is predominantly used, or sometimes ReLU, and so on and so forth. So at a very high level, this is how a neural network would look. It would typically have 3 layers: input layer, output layer, and a hidden layer. For some reason it is called a hidden layer, but most of the action actually happens there. And that can have multiple layers. So the hidden layers can be multiple, and that is where the depth of the neural network comes into play, and that's why we call it as deep learning, right? So the other is reinforcement learning. So reinforcement learning is where there's a slightly different model here. So you have, it is very helpful or very good at teaching systems to play games, especially games like this, Atari and so on, right? So it basically has a very simple model of a agent. So basically nowadays it has become very easy. There's just an API, and you just give your requirements to the API, and they will create the network for you. What I mean by that is we write our program using Python. So if you remember in machine learning, I mentioned three categories, right? So we have a program, we have the algorithms, and then we have the data. So we write our program and we use some of the existing libraries, like for example, for deep learning, we use TensorFlow, right? You are familiar with TensorFlow. So in TensorFlow, there is an API where you can specify, I want a neural network with 5 layers, and whether I want what type of neural network, fully connected, convolutional neural network, RNN. I specify the type of the network, how many layers I want, and in each layer, how many neurons. So by the way, a very honest, disclaimer. Nobody has a complete understanding of how neural network works. You can ask any expert, they know it works, but nobody can really say why it works or how it works. that every expert, even Andrew Ng, you must have gone through his courses, right? All of us admit this works, but we really don't know, right? At the very depth, we don't know how it works and why it works, right? So same way, even these, right? So a data scientist time, a lot of our time goes into doing this trial and error. We try out something, some configuration, it works, it doesn't work, then we try something else. Even as simple as one of the earliest experiments done with this was the handwriting character recognition, MNIST. I don't know if you're familiar with, right? So even there, people have tried out, and then they said that instead of sigmoid, you use ReLU, and the performance increases, accuracy increases drastically. But nobody is able to explain why is that. Instead of sigmoid, if you use ReLU, nobody knows, right? So that's a given fact. We have to accept that, and we have to work with that. There are a lot of considerations, I would say, not really thumb rules, because obviously if you make this too deep, it will never end, right? It depends on your processing power, what you have, what kind of data you have, how much iterations you want to do. All that put together, yeah, those are some of the thumb rules, and again, that comes through experience and practice. Okay, so so reinforcement learning is, again, this is very common in deep learning, and the idea here is it's very simple actually. There is an environment and there is an agent, and then you tell the agent what is the final your goal. Like for example, while playing the game, okay, all it just plays like a human being. That's the thing. So it doesn't understand the environment inside the logic of the game. For example, it doesn't know at all. All it knows is that in this case, for example, all it knows is that like a human being, it sees the score and it sees that, okay, there is a ball here. I have to move my cursor this side to hit the ball, or this side to hit the ball, and then every time I do that, it goes up, and if it falls down, I lose my life. That's all. It knows only this much, just like a human being. And then you train it. You let it play, and you give it a goal, and we have seen that this really works phenomenally well. Okay, so there is a demo for that. Again, let me just play that. So there is no audio here, but I will talk through. So again, this is for that game. When it starts off, you will see that like any new player, you make mistakes and you just lose lives, right? So it's hardly scoring. And then after about 2 hours of training, you'll see that it will play almost like an expert. It's not losing at all lives, right? But even more fun is there in the next, after training for almost, for okay, see what it has done. It has dug a tunnel and sent the ball the other side, right? Which typically we would not even think of something like that, right? So that is the power of AI, right? So in some cases, they really are better than us. So supervised is more generic. Reinforcement is, you can say, one very specific way of supervised learning. Supervised learning in general is whenever you provide data or labeled information, some previous historical data, that is supervised learning, right? So that's a very generic categorization. Supervised learning, unsupervised learning. Unsupervised learning is when you don't have any historical data, you let the system decide. So typically it is used for exploratory activities, clustering of information and so on and so forth, right? So in that sense, but this is reinforced learning is one very specific way of supervised learning. So what are the applications, AI applications? As I mentioned, I think some of these are autonomous vehicles is one of the biggest ones. Then the second is a lot of robotic process automation, right? So we have heard a lot about job losses and so on and so forth, right? So how we must be wondering how this happens. So let's take a look at some of these. I'll start with the autonomous cars. I have a few videos. So this is how they test the cars in the beginning. So now what we see today is as if it's working flawlessly, but as you can see, this is how they train. So it does end up making mistakes, right, in the beginning.
Holy cow. Whoa. Whoops.
That was a
Wrong
close
way.
Okay, so somebody is actually then taking over because this is really after training for several miles. Okay. So there's one more, and then I'll tell you basically how this works.
Oh yeah, good. The universal sign for auto. So cool.
So what does it take to build an autonomous car, right? So it is not just the software, obviously. It needs a lot of help because the sensors, like human beings, we depend on all our senses, eyesight and hearing and so on. So there's quite a bit of this is almost, I think, worth, I think there was a number I thought it has about 150,000 $150,000 worth of equipment in the car. Okay, so obviously you need all these equipment to find out the environment. So what they do is they basically provide, so GPS provides the location and other details we are very familiar with. I think some of the things that we are probably not familiar is the LiDAR. This is similar to radar, but it is more with light. and of course video cameras and then infrared cameras all around. So with all these equipment, the car has pretty much all around it the information all around it has, right? So who is next to the car and front, behind, everything. So more than human beings, for example, we can't see unless we see in the rear view mirror. We can't see if something is coming behind us, right? So it can continuously actually keep an eye on what is coming, right? In addition, it is also provided with the latest the maps, and in fact it works on 3D maps, I understand, nowadays, right? So it has the latest maps, and it processes all this information on board. So it needs a very powerful system. So there is an AI system which is sitting inside. So information is coming instantly, and this the maps and other information, obviously they have to download it one time for that particular area, and then from there onwards the local onboard AI will take over, right? So all basically it has to do is, and obviously as you can see here, it has been trained based on the visual inputs and all the inputs, that if there is a red light, for example, that it has to stop. If somebody comes in front, it has to stop, and all this. So that is the training that is needed, that happens with the car. And after that, once it is trained, it kind of all it does is, okay, is it safe to move? Then it presses the accelerator. If there is a danger, it presses the brake, and if it has to turn the steering, it just does the steering wheel motion. That's pretty much it. So these are basically what it has to decide, right? So whether it has to go forward, slow down, steer the wheel, and so on. All right. The other application is robotic process automation, right? So this is where there are quite a few things that are happening. For example, the chat bots, right? So nowadays, the chat applications were introduced quite some time back. You go to a website, the chat application comes saying, "Can I help you?" And then, once you type in, actually a real agent used to respond saying yes, for all types of chats. But now they are replaced with bots. So that is one automation that is happening and very common now. Pretty much everybody has that. But in addition to this, there are a little more complicated ones as well, where it involves, let's say, voice, right? So somebody calls up the service center or the sales center, interaction center, and he has a question. So it's not so easy unless you have really good voice recognition systems, right? So I think that is where quite a bit of advances have happened now. Let's see.
Welcome. My name is Dennis Noto, and today I'm going to take you through a unique experience. Last time you met with IBM, you saw a demo on an iPad app that talked about getting status of an insurance claim, very much like this one.
Hello, I'm your personal insurance virtual assistant. You can ask me about anything.
Now, the power of IBM's Watson platform goes way beyond just the mobile application. In fact, Enterprise Platform is embedded in every sense of what we're developing at IBM. So what I want to take you through today is, yes, what if we hook this into almost any appliance, everyday appliances that people use in their homes, to give it a unique experience. I have my little friend here, Amazon Echo, which is making an enormous impact on our everyday lives in the households of millions for asking simple questions. Say something like this: Alexa, Wikipedia.
Okay, what would you like to look up?
Artificial intelligence.
Artificial intelligence, AI, is intelligence exhibited by machines. In computer science, an ideal intelligent machine is a flexible, rational agent that perceives its environment and takes actions that maximize its chance of success at some goal. For details, say "Tell me more."
No, thank you. So what if we could harness this device as a front end with the powerful back end of Watson. Let's see what that would be like. Alexa, open Watson.
Hello, I'm your personal insurance virtual assistant. You can ask me about anything.
Can I get a status of my claim?
Hi Dennis, I see by our records that you are a policyholder with open insurance. Is that correct?
Yes, I am.
Dennis, we are sorry for your loss. I see by your recent claim that a tree appears to have fallen on your roof. Can you confirm?
Yeah, what a mess.
Looking at your file, I see that Mr. Fred Balboni filed his report with us on October 1st. Coverage was confirmed and we issued a letter to you with instructions on October 5th. Have you received that letter?
Nope, never got it.
Sorry you didn't receive your letter. Based on the contents of the letter, your property coverage is replacement cost up to the agreed assessed replacement value of your house. We see from the adjuster's notes that this should be well under the amount. You should have plenty of coverage. Any questions about your claim or coverage?
What are my deductibles and limits?
Your deductible is $5,000 per claim. There are limits on the dwelling of $1.2 million, liability of $1 million, medical payments of $10,000 and contents at replacement cost. Anything else on your mind?
How do claims work?
Awesome question. The letter we sent you provides details on the process and commonly asked questions. I will walk you through the process.
Okay.
Dennis, the letter advises you on the coverage for the roof damage and any other related damage, cleanup, and items required by city ordinance. May I continue?
Please do.
You may choose your own repair service, but we have provided you. I can set up a time for your representative, George Jetson, to call you. He is available 4 p.m. today, 9:30 a.m. tomorrow, or 1 p.m. tomorrow.
1 p.m. tomorrow.
Great. I have created an appointment for you and George for 1 p.m. tomorrow.
Thank you.
You're welcome, Dennis. Just trying to bring a little comfort to your life.
Goodbye.
So that is, as you can see, it was pretty much like how a human being would interact, but there is actually no human interaction here exactly, right? And so if you see here, it has actually, the system has probably tried to access multiple systems. So it identified the person, and it also identified that a letter has been sent, and also it could check somebody's calendar, some employee's calendar, to set up a time as well, right? So ultimately, so it's pretty much like at no point in that interaction was a situation where the system did not understand and it said, okay, let me put you to a real person or anything like that. It was pretty advanced and it was able to handle, right? So this is one kind of automation that is happening. So this is another kind of automation that I think basically the one which I showed you is a little more advanced, but this is probably already in production. A lot of companies are using it. Anything which is, let's say, manual or monotonous, like there are a lot of activities in the ERP space, like for example, companies receive invoices, and these invoices from different vendors come in different formats. So they outsource this activity for somebody to take all those invoices and key into their system, right? This is a very mechanical and monotonous job. So those kind of activities today are already being automated, and that is, people are already doing it. This is a small example of that. What we created was a POC for, let's say, patient registration. This is a little more complicated than just doing this invoice input. So here we spent a little time with one of the hospitals, and they had a very nice, very streamlined process. This was Arvind Eye Care in Coimbatore. Okay. So when we were actually doing the other project, we had a tour of their office, of their premises. So one of the bottlenecks they said was at the patient registration. They try to automate it, but very often the people who come there are pretty much illiterate people from villages and so on. So even though they have kiosks for self-registration so that they don't have to wait in a queue for somebody to actually create this registration, still they are not able to enhance or speed up that process. That's one of the bottlenecks. So we are creating, or we have created a small POC whereby nowadays Aadhaar is a common thing for everybody, right? Even in the villages it is there. So can we, if the person has to just come and put the Aadhaar card there, and automatically the registration will be done and the registration card will be printed out. So this is a small demonstration of that. So if you see here, basically, so let's say the card is scanned and it is available in a particular folder. That process also can be automated, but we couldn't demonstrate it here. It is doing OCR basically, right? Character recognition. It reads the name, the gender, and mobile number. These are of course dummy Aadhaar cards. Again, this is a demo, so it is taking a little while, but that can be much faster once the training is completed. So it captures all the details and then it will go into the system. In our case, we just did Google Forms, but if you have a actual system, we can put it into that as well, right? And then it triggers the print command to print the So since in our case printer was not readily available, we just printed to a file. So this is one kind of, and it repeats, right? So if you have multiple people who have done registration. So in addition to this, basically I wanted to show a couple of live demos on our system, but since I'm not able to use it, I could not. But I think this is how AI is used, and these are some of the applications. I hope you got a good idea. Any questions that you have?